Our next session is Chandrayaan and Beyond, India's Space Race. We have Professor Gautam Desiraju, scientist and author, and Professor Aloke Kumar of IISc Bangalore in conversation.
Hello. Hello. Are we audible? Okay, good. Good afternoon, everyone. See, Professor Aloke and myself are very thankful to the PLF for having asked us to come here and give this short descriptor on Chandrayaan 3 and the long-term significance of this for our country. Now, the first thing is that science and technology very different from some of the other topics we have been hearing about in these sessions today. It's very true that about 99% of it is perspiration, and the devil lies in the details. And in an audience which consists predominantly of generalists, the presence of two specialists here, like Aloke and myself, he is trained in mechanical engineering, but now his research has a great deal to do with space technology. I am a structural chemist myself, and both of us are from the Indian Institute of Science, Bangalore. Now, why is this Chandrayaan 3 so important? For a start, let me say that mostly it has been an engineering job. Politicians and others say our scientists have put us on the moon or something like that. But you are all lay people, and you will talk with other lay people about topics like Chandrayaan. And let me be very clear that there is not a whole lot to do with science here, but a lot to do with engineering. The technology component, in the sense of certain invention steps, is also there. But Alok, wouldn't you say that mostly it has been an engineering job, and a collection of very good engineers assembled by ISRO have managed to do this extremely difficult task? Make no mistake about it. Whether it is science or technology, let me say that these subjects are extremely difficult. I will say this with a certain amount of, I suppose, arrogance also. Compared to many other subjects, the difficulty level in science and technology is very, very high. This is something that should be borne in mind by many people. It's not so easy to become a good scientist or a good technologist. And as a result, something like Chandrayaan, which involves so many people coming together to get a final precise result the way they've got it, is something that is extremely praiseworthy, and we need to take note of this fact. What do you think, Aloke?
Hello now? Okay, great. By the way, we played 3 videos for you guys in the beginning. I hope all of you recognize that these are the videos from ISRO as Chandra. The first one was as Chandrayaan was approaching the moon, and the second one was as it was landing, and the third is the Pragyan rover roaring out, right? It filled all our hearts with so much pride. At least on the ISC. Did all of you see it live? I hope, right? So there was so much pride also at that day. I was on the ISC campus, and it was being screened at multiple locations everywhere, and there was so much excitement in the minds of the students. And there is a reason why we say that this is not rocket science, is because most other engineering is not that difficult as rocket science. Here, you don't get second chances. We saw with Chandrayaan 2, you get one chance, and if one small thing goes wrong, the entire mission is over, right? So it can become, Chandrayaan 2 was obviously a heartbreaker for us, but then the nation rose up, it did Chandrayaan 3, which is a very big engineering challenge. And as Professor Desiraju said, this on the science aspect of it, there's still more, this was so much more driven by engineering, technology, and how we can get a vehicle such to so many million miles across and have it land at a very pinpointed location was the most important challenge. Obviously, that's something that has been done in the past too, right? So, Professor Desiraju, I mean, we are happy that we are fourth.
No, yes.
But we are still fourth.
No, we are one of four. And let me say that it is going to be very difficult for another country to get into this club of four. The technical difficulty of doing something like this, I mean, there are scientific things. We don't want to get into really scientific details and jargon. But the fact that the gravity on the moon is only 1/6 that of the Earth, and the fact that the moon has no atmosphere, make the engineering calculations quite difficult. And the landing, especially that last few seconds when the thing has to land properly, the so-called soft landing, is extremely difficult. But I want to change gears a little bit. Chandrayaan is an example, since also the nature of the audience and the kinds of things we've also been listening to. It's an example of the state flexing its power. And there is a political implication to something like Chandrayaan. The very fact that we are one of four, the fact that the Russian landing a few days before failed, and that Japan is tentatively saying we're going to do something in a few weeks or a few months, all this definitely puts India on the top. A very intriguing fact which I noticed, which many of you might have seen also, is that the successful Chandrayaan-3 landing has had a very strange effect on our Western neighbor. Now, some of the videos that you have been seeing, the popular videos on the streets of Lahore and Peshawar and Gujranwala and all those places, suddenly somewhere the Chandrayaan thing seems to have been a turning point. Those of you who are perhaps in my age group will realize the devastating effect that that sixer by Miandad had, that full toss from Chetan Sharma, I think his name was. I think it set the whole country back psychologically by 10 years minimum. This Chandrayaan thing has had a similar effect on Pakistan. Suddenly they seem to have realized that there is no way in which they can even begin to compare themselves with us. And I saw a funny video a few days back, many of you might have seen it, when a guy was saying that ठीक है वापस कर देंगे, let's give ourselves back to India. And somebody else said that let's make Modi our prime minister, let him take over for 8 years and sort us out properly, because we're not able to sort ourselves out. So it has had some Indian satellite landing in some south pole of some moon has had an effect on Pakistan that we could not have imagined. I certainly wouldn't have imagined. I don't know if anybody in the audience would have imagined that this is the kind of devastating psychological effect it has had on Pakistan. A kind of implosion, as it were, of their entire country. Somebody else said about Jinnah, he said, "Kya kuch free plot diya hai humko." So what have we done with this free plot? He went and died a year later. Something like that. So it has had the strangest of effects, which means science and geopolitics can actually come together. And I think the feeling that if this particular audience, this is not a scientific audience, but this relationship between science and geopolitics is something that I think this audience should take home, because this science is now not done in a single silo with scientists. We are not some funny guys sitting with some white coats and going into the lab and talking funny. We are normal people like everybody else. Okay? So we are not some strange species, the so-called mad scientists and so on. We are as mad as anybody else in the audience. So, but the geopolitical implications of science, I think, are now abundantly clear. What do you say?
So, I don't know if you remember, I saw one particular video where there was one Pakistani fellow who said, we are already on the moon. I mean, the Indians have sent a rocket on the moon. We are already on the moon because we don't have water. There's no water on the moon. We don't have electricity, just like there's no electricity on the moon. That was funny, but I think it's an important indicator of the geopolitical aspect. I don't think Prasanna is here, but I would have to love to ask him. This is August 2023's edition, and he says, here, a perfect soft landing of Chandrayaan-3 on the lunar surface will propel India to new heights in space exploration. So maybe Swaraj should come out with one more saying it has propelled India to newer heights. But talking about geopolitical implications, right? What is it that we are looking for on the moon? Minerals? What kind of is it just for the fun? I mean, I know that Elon Musk, on the public persona that he has made this idea of visiting extraterrestrial worlds or space, something, or just space tourism, something that has caught public attention. But I think it's much beyond that, right?
No, Mrinal, it's not fun. No country will invest in something like space research, extraterrestrial research technology just for fun. It's too serious a matter and too grave a matter. The fact that so many countries are not able to do it itself shows if it was just something for fun, some Disneyland or something, then many countries would have started doing it. So no, it's not for fun. Minerals, maybe. I think already we have seen that there's nothing unexpected in this. The soil that they have already looked at has aluminium, calcium, iron, chromium, titanium, manganese, etc. This is the common constituent of Earth in the terrestrial soils also. Now, the thing about the lunar landscape could be a different proportion, of some of the elements. And here I want to refer to what are called these rare earths. Do you want to?
Are they really rare?
No, they're not rare. They're called rare earths for historical reasons. They're not rare and they're not earths. So, but they're a very strange group of metals, beginning with cerium and ending with lutetium. They come way down in the periodic table. Now, imagine a family for some reason which had 14 identical twins. They were born. It's impossible actually, but 14 twins, babies were born who look just the same from the outside. And let's say that deep inside in some of those organs of these 14 babies, there are some small differences. And these small differences, given the nature of the human body itself, could result in profound changes in the behavior or the health or whatever of these babies when they grow up. The rare earths are like that. On the outward surface, they all seem to be the same. They all look the same. They are all hard metals and so on and so on. They're all extracted in the same way. But they have very, very different properties and very specific different properties. For example, every cell phone that all of us are carrying has got a certain rare earth called europium. Every motor car that you're driving today has got something like 20 kilograms of a rare earth called cerium. Cerium actually is one of those things that's very common. It is the 24th most common element in the Earth's crust. So each of these rare earths, which look so similar, are actually used for very different things. You can't use cerium in a cell phone and you can't use europium in a car. That's that kind of thing. Now, because they are so similar, it's very difficult to get them out. And right now, for reasons which we can't get into now, China has got a near monopoly on these rare earths. Now, this is something that many people have heard in the popular press. Now, the question of where this comes in with lunar research is that the composition of these rare earths on the lunar soil may be quite different from what it is on terrestrial soil. So, for example, there is one of them which is extremely important but very rare. It's called dysprosium. Now, this dysprosium, only Australia seems to have a bit of it today, which is why that Australia country is a bit important in this rare earths politics. Now, it may be that the lunar soil contains much more dysprosium than the terrestrial soil. And there are good scientific reasons for this. We can't go into the details, but it has to do with that the gravity on the moon is only 1/6 that of the Earth. So these rare earths, the way God made them and put them on the Earth's crust, depended on some ancient tectonic events and when the Earth itself was cooling from a molten mass. So that's how all these rare earths came into being in various places on the Earth's surface. So it could have happened that the lunar composition is very different. And this would be important. This would be important because then it leads to this question of space stations. So if we could have a space station with people living there and a suitable way of mining these rare earths and bringing them back, it would be worth the money, I think, Aloke, if we could get a lot of dysprosium onto the earth. Because don't forget another thing, true of every metal, there are finite supply on the earth's surface. Another element called indium, which is present in these cell phones, is going to run out in 100 years. There's going to be no more indium left. So of these elements in the periodic table, we are also going to have extinct elements after some time. Because human beings are using these elements in very irresponsible ways. When you take the cell phone and then the cell phone goes out of order, finally you have to just trash it and throw it out. And there is no way of recovering the europium and the indium from these cell phones after some time. So all that is essentially gone to waste. So as a result of this, there may be big implications in these lunar missions and space missions in general to extract elements that we may need. Now all this may go very much against the principles that we have heard in many of the talks before this. But we are hardcore scientists here and we have to live in the modern world with all the realities of the modern world. So if this becomes exploitative in terms of extracting minerals, materials and so on from the earth, then this is what, we all have to do, because we can't go back to more primitive kind of living which people used to do before.
So, I'm not a chemist, so I don't remember the names of all the metals. But from what you said, what I understand is that these rare earths and other metals, they are becoming increasingly more important in our economic cycle. We are increasingly dependent on them. If we do not have access to the supply chains for them, our current way of life will be totally devastated. Is that right?
Yes, I'm going to take a little excursion to talk about what China does with these rare earths and how they came into this predominant position. Like many other things that China has done, this is a pretty nasty story. These rare earths are a little difficult to extract from their oxides. They exist in the form of oxides. So you have to get the pure metal. Now, the process of getting the pure metal from the oxide is extremely polluting. It involves all kinds of dirty chemicals like acids and various leaching agents, very nasty compounds. Human beings should not be anywhere near those compounds. So what China does is it imports ores. It's got a lot of ores. As Aloke says, rare earths are not rare. They are all over the place. India has got more rare earths than it knows what it's got. The problem with India is we don't know where the rare earths are. We'll come to that if we have time when we talk about the monazite sands in Kerala. But okay, what China does is it takes these ores and sends them all to uninhabited places in Mongolia. Nobody lives there. So vast areas of Mongolia are now become environmentally, they're a disaster area. They do all this polluting chemistry in those places. Whole rivers and streams and everything. They don't care what they do. No other country wants to do it. America had a lead in this rare earths. There is a place called Mountain Hill in California, which has many of these rare earths. It became so polluting. And at the time of this Kissinger-Nixon detente with China, one of the things that China wanted was it wanted America to stop mining rare earths. The Chinese were so clever way back then that they realized the strategic hold that they would have by mining these rare earths. So this Nixon and Kissinger actually gave up control of this rare earths business. And the Chinese started doing all this dirty chemistry, getting the rare earths. Then they started getting ores. Chinese have even bought islands in the Indian Ocean. They bought up whole islands just to take out the rare earths from there and take it all to Mongolia. And then they make the rare earths, and not only that, China also makes the finished goods which require those rare earths. In other words, they control the whole supply chain. Starting from getting the ore, getting the rare earth, making the device, then they can do what they like with the prices. There is a famous dispute called Shinkaku Island dispute with Japan in 2010 or so. when suddenly China stopped supplying neodymium to Japan. Neodymium is another of the rare earths that is used for permanent magnets. Again, vital. Without neodymium, you can't make those magnets. That is the tragedy of these rare earths. So then the price of neodymium went up 10 times. Even today, the price of lutetium is 10 times the price of gold. People don't realize how valuable these rare earths are, and China has got a stranglehold in the whole world. So we've got, on the other hand, USA, Australia, Japan, India. What are these 4 countries I'm mentioning? These are the Quad countries. So the Quad, which was defined for some safety in Pacific and all that, the hidden agenda behind that Quad is to somehow prevent China from getting a full control on rare earths. And Deng Xiaoping, the clever man that he was, probably the cleverest Chinese person in the leadership, said in 1991 itself, the West Asia has got oil, China has got rare earths. And he said rare earths will become the oil of the future. 30 years ago he was able to say this, 35 years ago he could say this. And now today they are in a dominating position. USA, India, Australia and Japan.
So
Japan is the major consumer now.
So the bottom line of this is that either we are, if you want to protect our natural resources and our, let's say we don't want to be that polluting, then we either depend on a supply chain that lies totally outside of India and that can be choked at any point, or we utilize our resources. But here I think space is where it gives us a third alternative, which is we don't if we are able to reach to the moon, if we are able to, whether or not moon is economically viable, that only time will tell. But we have to first get there to be on the table. So if we find that moon has these good regions from where mining can be economically sustainable and some of these rare earths can be mined, we are not going to look there for gold or platinum, right? These rare earths are the future.
Nor are we going to try to take potatoes there and make them into gold or something. This is what I think somebody said. But rare earths may be today's gold. I don't know. If we have a space station that's working, it is entirely possible that, say, 50 years from now, we would be able to do metallurgy on the moon's surface. I don't rule this out. I mean, 50 years ago, America put a man on the moon. He actually walked on the moon. And 50 years from now, who is to say? And given the fact that science and technology are moving at exponential speed now, the time scales of science and technology are shortening all the time. So things that we never thought were possible would be easily possible. That is why the symbolic importance of Chandrayaan 3 is really, really huge.
So, I mean, this is, at the moment, this is still driven a lot by curiosity, a lot by a sense of adventurism, that other countries have reached the moon. We also want to reach there. There is obviously a lot of interesting science that will be probably possible. So, by the way, one thing just to quickly mention, moon and earth have, from astrophysical theories, have had some kind of a common beginning. And because of that, the rocks and the sand that you find on the moon, there are areas on earth where you will find very, very similar soil. In fact, if you have seen any construction site, especially in Bangalore, they use this white sand, right? So it is very much like that because it is, in a sense, a rock called an orthosite, and that has a lot of aluminum. It has other metals as well, and maybe there are other regions which will be useful on the moon as well. So as we look into more and more of where if once we map the minerals there, right?
See, Aloke's comment, and I think now we have given you enough introduction to scientific topics so that now I feel emboldened to try to explain to you a little bit about the difference between science, technology and engineering. Many of you in the audience I know have an engineering background, but I don't know how many of you have a science or a technology background. Now, all these three subjects, they are quite different from each other. You should not think of, scientists have put us on the moon surface. No. Scientists have not done it. Engineers have done it. Okay, so now let me give you a familiar example. And I don't know if some of the people in the PLF will object to my using this name, but he is the person who started modern science in the Western way, and that is Galileo. And I think mentioning Galileo is especially appropriate when we are talking about extraterrestrial research, because he is the one who really got us interested and all in the modern era. I am not going to consider what we might have done in this country in the earlier era, and I don't want to get into that topic also because it is not our domain expertise. Now, what did Galileo do? He did something very interesting and curious. He was many skills rolled into one person. There was a Dutch guy called Lippershey who was fooling around with convex lenses. And he took convex lenses and he saw that he could start seeing objects bigger than they were, magnified. So this Galileo took this result of this Dutch fellow, and the first job he did was an engineering job. He took those two convex lenses and made what is called today a telescope. And in this telescope, when the Dutch person was putting these convex lenses, he was getting an inverted image of the object. Now, it's not very nice to have a telescope and see the object inverted. So, Galileo was able to get an upright image. So, the first job he did was an engineering job. This is usually counterintuitive. Engineering comes after technology, which comes after science. But Galileo started with the engineering part first. What did he do next? He had this telescope. And he then did two things with it. He took it first to the Duke of Venice. And then he took the telescope and put it like this across the water, in Venice. Venice is on the Adriatic coast. And he told the Duke, with my little gadget, you can see the Ottoman ships as they are coming into Venice long before they know that you can see them. Now that is technology. Let me just finish then. That is the technology part. Technology means imagining something and trying to get something that nobody could have imagined. Telescope in the hands of the Dutchman was just a way of looking at something bigger. Now he put it like this, and then you get technology out of it. So the guy got so impressed that he gave Galileo a fat sum of money. And this is something our technologists should do. They should know how to get money from kings and industrialists, which is what they don't seem to be able to do very well today. They're all talking all sorts of nonsense. But he did like that. And then he did the one last thing that he made it science. Instead of holding the telescope like this, he held it like that. And then suddenly he could see the moons of Jupiter. But that is science. This is technology. So you see, these are quite different. When he saw the moons of Jupiter, then he started saying all the planets move around the sun, Earth moves around the sun. It got him into big trouble with the church afterwards, but that is a different question. Maybe some of the others who have spoken in this can talk about science and religion and all that. We don't want to get into that. So you can see in the same one man, Galileo, there was engineering, technology, science, entrepreneurship, making money, all these things. But you must understand that all these things are different. Scientists are different from technologists who are different from engineers. Aloke.
So this is a very interesting story about Galileo. I think it is pertinent to this discussion, and I'll tell you why. So once Galileo got this telescope made, obviously he pointed it towards the heavens and saw the moon. He didn't fully understand what he was seeing. There was a little bit of chromatic aberration. He thought there was an atmosphere around the moon. That was not correct. But then he saw the moons of Jupiter. But this news that he had started seeing other things, the things that naked eye could not see, that traveled across Europe as lightning. And very soon, there are other scientists who are also good engineers. They started making more and more telescopes. They started seeing other galaxies, nebulae, star formations, clusters in more detail than humankind had ever seen before. In fact, and by the way, what's happening in India at that time, we have totally lost out on the game. We don't have this technology. It will not come here till almost 1800. So it's almost like a 200-year difference. Within that 200 years, the science, at least of astronomy, is something that we lose behind in total. We do not have by the way, this all culminates in bigger and bigger telescopes. Finally, telescopes get made out of mirrors, and then you have Hubble, who starts making some very important calculations, and he figures out, oh, the universe is expanding, and in 1930s, and all that leads to the big science of understanding how the universe was created in the first place. And the reason India is nowhere in the picture in this entire discussion is because of this one crucial technology that we totally lost out on.
See, what Aloke is saying is highly significant. Because in science, let me tell you, ladies and gentlemen, there are only two ways of going ahead. You either have to be first or you have to be best. There is no third way. And it is very difficult to be best because you don't know what that best is. We still don't know. But being first is easy. It's like seniority, in government service. It cannot be questioned. That's why it's so important. So, once you are first, given the telescoping timescales of science, the fellow who is first gets an enormous lead over the guy who is second. It is very, very, very important in science and to some lesser extent technology to be first. Like Bell Labs invented that silicon chip. They got it few years before the Russians and so many other people. So that gave America a huge lead in semiconductors, which they have still not given up. So that first business in science is extremely important. People outside science don't realize, and why we scientists quarrel so much about priority in establishing a result. This is why India is nowhere. Please don't go and just have some nice feeling that apne scientists to bahut achhe hain and they are doing all sorts of things. They put us on the moon. No. They didn't do. The science behind this was done 50, 60 years ago. See, Werner von Braun in Nazi Germany discovered the rocket first. They stole him after the war, brought him to America and made him head of NASA and all that. So they actually stole von Braun. So then the rocket technology came there. Most of the science in Chandrayaan 3 is ancient. The technology is also pretty old. There are maybe some new things in the periphery. Where we have scored is engineering. And even in engineering, let me say, Chandrayaan 3 has worked because it picked first class engineers from second grade universities. Our first grade, this IIT and all this junk, none of those fellows have come there. They've come from Trichy Institute, something, Cochin, Nagarkoil. They're all from such engineering colleges they have come, but they are first class people. So please remember, better to have a first class scientist from a second class or third class institution. Our so-called mediocre people from the IITs are junk. They can't do anything. That's why they run away to America and try to do something there. They cannot put Chandrayaan 3. I will stick my neck out and say this.
Okay.
No. See, Aloke and I, we have been in this line. We have seen all these guys in IITs and all these places. Only thing they have is this quota exam and writing and, committing suicide when they don't get into this is nonsense.
No, but this very mission also can inspire our children today.
Correct.
To understand that there's so much more to be done. In fact, something like astronomy is a fantastic hobby to understand so much science and so much technology. You can see the bands in light as it the wavelengths of this light that are coming from different stars. You can understand quite a bit of. You can at least get interested in chemistry from that. You can get interested in physics from that. You can get interested in engineering and technology from that. And I think it's very important for children to begin early and start doing these things and become, hopefully, the other set of engineers who will put now an Indian on the moon and an Indian on Mars.
Okay, I think so. I think that's going to happen pretty fast. Aloke, with your permission, and unlike some of the other speakers, I'm going to stop now because I want to give full 10 minutes for questions. So ask anything you all want. And as Faraday said, no question is a bad question. Only the answers can be bad. So please ask to your heart's content. I am giving you all 10 minutes to ask anything you all want.
Thank you, sir. So this
Can
psychology.
you please speak louder?
Yeah. Good evening. Thank you for both of you. This point that you made about the psychological impact the Chandrayaan 3 has had on our Western neighbor,
Yes.
I think the same psychological impact we have been having by seeing the scientific exploits of China
Yes.
for many years. So for science to develop, what my understanding is, it's very important to have an open world and receptive to ideas from outside. Can you try to explain how China, being a traditionally very closed society, has been able to dominate science so much?
They had one great man there, Deng Xiaoping, who realized far in advance. See, he was a very brave man because the whole communist thing is an economic doctrine at the end of the day. And he was able to dispense with that form of economics when he opened up China. So, for a communist to be able to change the economic model, it required true bravery. And if you want any more details, please read the article I have written with Rajiv Mantri, which appeared in yesterday's Indian Express. Not New Indian Express. Indian Express, on the editorial page, it has come. It is called Invent in India. So, what does it take to do inventions? Because this technology is all about inventing. Engineering is all about making. And science is all about what is called ideating, to create an idea, a new idea. How does a person get a new idea? We are not training our young men and women to dare to dream, to get ideas. And in keeping with the theme of the rest of the LitFest, like if you take the 4 voices that we have, Para, Pashyanti, Madhyama, Vaikhari, I am talking about Para. When the earliest germination of the idea comes somewhere deep within you and you don't know exactly what it is. So, what is it that makes Indians unable to get ideas? This is what we have to ask ourselves. This is our failure of our education system, which we have written about in that small editorial yesterday in Indian Express. But good question. Please, Dr. Chowgle. Please.
I don't have any doctor's degree, so so I just
ठीक है, Chowgle ji.
Okay. So I'm vice president.
You must excuse us.
Yeah.
We call everybody doctor. You know.
Yeah.
It's a habit of so many years. Yes.
No, you made an observation about the rare earths being a very polluting industry. It has been our experience in some of the industries which we have been, that industry, okay, like when it started 40, 50 years ago, was polluting. Then again, technology and science came, and even engineering. And the pollution levels today have come down, okay, quite drastically.
Correct.
One of our experience has been in controlling pollution is actually has benefited the economics of the operation also.
Economics of?
Of the operation.
Yes.
Controlling pollution is not a cost. What are the concepts that what we have, some other members in the industry have. So can the same thing not be done for these rare earths that you talked about?
See, very good point. See, China has got this huge advantage of scalability. And when you are able to do things at the scale which China is doing, many of these costs start coming down. India, in many of these cases, we are not operating at a scale that is economically, feasible and proper.
One thing I'll add to that is usually technologies at the beginning are not optimized to decrease pollution. Right? They're optimized to do something. You have to get X from Y, Y from Z. But then, if you have to make it environmentally better and environmentally more conscious, a lot of more effort has to go. What some of the other countries have done is they have quickly started mining, and by the time we change the technology, because if you have to make technology environmentally conscious, the amount of engineering and the amount of effort that goes can be significant. And there are many other technologies for which we still don't understand how to make it better. For example, cement manufacturing is still a huge polluter of CO2. So it adds a lot of delay. And by that time, your competitor might just get ahead. So that is one of the challenges.
Okay, there is another unfortunate aspect to this rare earths thing in India, which I am sure you know. And the fact is that cerium, which is one of the rare earths, a very common thing, is found in those monazite sands in Kovalam. And thorium is required for our atomic energy program. And so that thorium supply is controlled by the Department of Atomic Energy. Now, in the typical Babugiri that we are so famous for, cerium got lumped in with thorium. So all rare earths became the property of the DAE. So tomorrow if somebody has to find some europium or samarium in Chhattisgarh, he has to go to DAE. And these rare earths do not have any significance in atomic energy. Only thorium has. It so happens by a quirk of fate that thorium and cerium are found in that original beach in Kovalam. So now, after so many years, we have been unable to extract this rare earth thing from the Department of Atomic Energy. And so that it has stymied research in our area. There's hardly anybody doing fundamental research, good science on the rare earths themselves, or these properties that make them so useful. So you see, this Babugiri, it comes in all over the place like an octopus, and we are not able to proceed. Any other questions, please?
Good evening, professors.
Can you please speak a little louder?
Good evening.
Yeah.
Good evening, professors. I wanted to know how that ISRO did a hop jump, right, for some minute seconds on for Chandrayaan 3, that lander. Why was it important? And we have a 14 days off period for Chandrayaan 3, right, for both lander and rover. So how will it, after 14 days, suppose it doesn't work, so how it will be?
Okay, you asked two separate questions. One is why was the hop important, and why does it? Why is the 14-day cycle?
Yes.
So first things first. So eventually, what do we want? We'd want to bring back samples from the moon. We'd also, if we send a human to the moon, we'd want the human to be able to come back. So you don't just want a lander to reach there. You also want it to be able to come back. So that lander which has landed should also have the sufficient amount of fuel in it and the ability to lift off from that lunar surface and then come back to Earth. So the hop is a very minor form or a very simplified form of that experiment that they wanted to do just to see whether they can lift the Vikram lander back on again. That is one. The other is the 14-day cycle. Why do we have a 14-day cycle whereas Chang'e maybe has been working well for 4 years? Is because of the batteries. Our batteries are just chemical batteries, whereas for Chang'e they had a nuclear energy source which just keeps it. So moon, the temperatures vary a lot. So when it is night time, the temperatures drop to minus 200 degrees Celsius. Minus 200. I mean, everything freezes at that temperature.
This is the flip side of doing Chandrayaan on a budget less than that of a movie. So it's not altogether a nice thing because the poverty is never a virtue.
Namaste, sir. Two short questions. One, we've seen in the World War times that engineering for World War II resulted in a lot of science and technology in the future.
Yes.
Do you see that possibility post Chandrayaan?
Absolutely, yes.
That is one. Second is related to the previous topic that you mentioned. That is why we are not able to generate ideas in India. And I would like to go back to Thomas Kuhn's The Structure of Scientific Revolutions, an important book in the West, where he conclusively proves that every bend in science, every revolution was a contribution by non-scientific ideologies from outside.
Can be, could be.
And, but in India, why we are not able to leverage thought around us to make that
See,
influence.
too much premium is placed on conformity. The more you conform, the better you are supposed to get ahead in life. So, and the whole thing about science is not getting correct answers, but asking correct questions. And so we are scared to ask a single question. Then where is the question of asking a correct question?
My question is to, sorry, can I? Hi, here. Yeah, my question is to both Professor Desiraju and to Aloke, for the simple reason that Professor Desiraju will always give the correct answer. He's an oracle. And
So why is a direct answer bad?
no, I'm saying that Aloke belongs to the next generation. So I think this question, would be answered. It's good if it's answered by both. Is it must or should science be dissociated from politics? Let me elaborate on this question, to which I seek answers from both of you, because Professor Desiraju said during the course that China produced one great leader, Deng Xiaoping. That same man mowed down innocents, 10,500 innocents using tanks in Tiananmen Square. You talked about von Braun. He worked for the Nazis to generate a weapon that killed thousands during the Blitz in London. On the other hand, you had Heisenberg, who deliberately slowed down the Nazi nuclear weapons program. So the question is, should scientists be happy that they are discovering things in their lab that can change the world, while their lab and their funding is controlled by dictators and Nazis and evil people? And the obvious question is that if tomorrow India were to be ruled by a dictator, I say tomorrow, to be ruled by a dictator, and the dictator were to ask both of you, scientists, to develop a bioterror weapon or a nuclear weapon, would you go ahead and do it? Thank you.
Are you asking this question as a scientist or a TV news commentator?
A question should be treated as a question. Just answer it, please. Thank you.
Okay.
Then you answer.
So, as far as the history of science is concerned, yes. So, science is agnostic to who discovers something or who invents something. So, what were the motivations behind somebody's inventions? Who funded it? Why they funded it? Time has shown that science is agnostic. Even engineering is agnostic to that. Developments in the field happen whether they were funded with a good idea in mind or with somebody wanting to wield tyranny on the world. And whether I like it or I don't have an opinion on it, because that's just the reality of it. And that may happen again and again, and hopefully not. But hopefully it will be funded by people who have big hearts. But that's something, just the reality of the situation. And as far as I would do it or not, it's a very hypothetical question.
See, he has now given a direct answer. I'm going to give an indirect answer. So it's not true that I always give direct answers. So I think the problem is that when science and governmental things start getting mixed up, science as done by a university person in an academic lab should be agnostic, like what he said. We do things without worrying about what implication it may have. Now, since it is done in this country and directly or indirectly it is the property of this country, assuming certain patents and all have been taken and some important discoveries, it is up to the government then through the national labs, through various systems of private industry, government, private partnerships, to decide what to do with it. I don't think that, I know there have been many movements when scientists started complaining about the fact that their work led to all sorts of things. But I don't think you should put a very heavy burden on academic scientists, because we are guided only by two things. First is a curiosity to find out some new thing. And second is a certain amount of courage to tackle a question that many people feel are impossible. So if you have two things, you just need two things to be a scientist: curiosity and courage. So once you have that, I think you should not ask the scientist anything more about why, because what somebody may do with that result. Somebody could take that result after 10 years down the line, even after you're dead and gone, and then do something with it. So I think it's that way. In that sense, I think the question also is kind of, a little bit ambiguous. Yeah. Sorry, I think we are exceeding our time.
Okay, so we'll conclude. Yeah. Okay, so again, once again, thanks to PLF for this fantastic opportunity for these two quirky scientists to come here and discuss Chandrayaan, and thanks to all the engineers of Chandrayaan 1, 2, and 3 for the success that we saw recently, and hopefully more will come.